Welcome to this episode of the CompTIA Tech Plus Prepcast by baremetalcyber.com. Let's begin. Peripheral installation refers to the process by which a device is recognized and configured by a computer system so that it can function properly. In most cases, this happens when new hardware is connected to a computer for the first time, but installation steps can also be necessary after operating system updates or hardware changes. There are two primary installation methods: plug and play, often abbreviated as PNP, and manual driver installation. Understanding both of these paths is important for efficient setup and accurate troubleshooting. In the CompTIA Tech Plus exam FC0-U71, you may be tested on when and why each method should be used. Plug and play is a technology that allows the operating system to automatically detect and configure new devices as soon as they are connected. This is the most common installation method for modern devices, especially those that connect via USB or over wireless connections such as Bluetooth. PNP works by reading a unique device identification code and matching it to an appropriate driver in the operating system's driver library, or, if needed, downloading it from the internet. This results in fast setup with minimal user interaction. Operating system support for plug and play is built into all major platforms, including Windows, Mac OS, and Linux. These systems maintain libraries of both generic drivers and vendor-specific drivers that cover a wide range of device types. Common peripherals such as keyboards, mice, and flash drives typically work immediately upon connection with no manual configuration required. If a newer driver is available, the system may connect to an online driver repository to download and install it. Over time, operating system updates expand compatibility by adding support for new devices. The advantages of plug and play are clear. It allows immediate usability for standard devices and reduces complexity for non-technical users. Because the driver is chosen automatically, it minimizes installation errors caused by mismatched or incompatible drivers. This method is ideal for devices with generic or widely supported functions, such as printers that use common printing protocols or webcams that use standard video formats. However, plug and play also has limitations. The automatically installed driver may not be the most feature-rich version available for that device. Some advanced features may require additional manufacturer software, such as control panels or utilities. Older or specialized devices may not be recognized correctly, and without a network connection, the system may be unable to retrieve the proper driver. Manual driver installation involves the user actively selecting or downloading a driver package and installing it on the system. This process is necessary for certain specialized devices, enterprise hardware, or in offline environments where the operating system cannot download the driver automatically. Drivers may be provided on a compact disc, a U-B flash drive, or from the manufacturer's support website. Installation wizards or tools such as the Windows Device Manager guide the user through the process. Use cases for manual driver installation include enterprise-grade printers that require custom drivers, gaming peripherals with specialized functions, and industrial equipment that relies on proprietary communication protocols. It is also necessary when working with legacy hardware that is no longer supported by default operating system libraries. Beta drivers, which may offer fixes or new features not yet included in standard releases, must also be installed manually. In secured enterprise environments, automatic installations may be disabled entirely, requiring all driver updates to be handled manually by IT staff. Driver signing and compatibility checks are important parts of manual installation. A signed driver is verified by the operating system as authentic and stable, while an unsigned driver may be blocked or flagged as a security risk. The driver must be compatible with the operating system's version, its architecture, whether 32-bit or 64-bit, and sometimes even the build number. Installing the wrong driver can lead to crashes, hardware malfunction, or overall system instability. In Windows, the Device Manager is a central tool for managing drivers. It allows you to manually update, roll back, or remove drivers. It can also be used to browse for driver files stored on your system, or to instruct Windows to search automatically. Devices that lack a working driver are flagged with a warning icon, making it easier to identify and address problems. IT professionals use Device Manager extensively to handle hardware-level configuration and troubleshooting. There is also a distinction between basic drivers and full driver packages. A basic driver enables core functionality, such as printing a document or playing audio. A full driver package includes additional software such as control panels, advanced configuration utilities, or diagnostic tools. For example, a scanner's basic driver might allow image capture, but the full suite might enable batch scanning, optical character recognition, and custom workflows. Choosing between a basic and full package is a balance between functionality and system resource usage. Troubleshooting installation failures is a key skill. Common causes include driver mismatch, missing driver signatures, and incompatibility with the operating system. Rebooting the system, reinstalling the driver, or using compatibility mode can often resolve these issues. In some cases, examining installation logs or error codes can reveal the root cause. If problems persist, rolling back to a previously working driver is a safe fallback. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. Once a device is installed, keeping its driver up to date is important for maintaining stability, performance, and compatibility. Driver updates can introduce new features, fix bugs, or improve communication between the hardware and the operating system. Updates may be installed manually by downloading from the manufacturer's website or automatically through operating system tools such as Windows Update or vendor-specific software. Some systems will notify you when an updated driver is available, while in other cases you may need to check version numbers to confirm that you are running the most recent stable release. Sometimes a new driver can cause system instability or result in a loss of functionality. In these cases, the rollback feature in the Windows Device Manager allows you to restore the previously working version without completely uninstalling the driver. This is a safer approach than removal, especially if the device is critical to the system's operation. After rolling back, you should test the device thoroughly to confirm that the issue is resolved before deciding whether to attempt another update. Installing legacy hardware presents its own set of challenges. Older devices may not have plug-and-play support or current drivers included in modern operating systems. In these situations, you may need to locate legacy drivers from the manufacturer's website, archived support pages, or user forums. Sometimes you will need to run the installation in compatibility mode, which simulates an older operating system environment, and administrative privileges may be required to complete the installation. Some legacy devices are simply too outdated to function reliably on current systems, even with the correct driver. Driver conflicts and duplicate devices can also cause problems. If multiple drivers are installed for similar hardware, resource conflicts or device errors may occur. Symptoms of these conflicts include the device not responding, system freezes, or frequent disconnections. These issues can be resolved by removing redundant drivers, disabling unused hardware entries, or reinstalling the correct driver for the specific device identification code. Maintaining one clear driver match per device is essential for stability. The behavior of USB devices can vary depending on the port used. In some operating systems, plugging the same device into a different USB port may cause the installation of a separate driver instance. High-speed devices, such as external solid-state drives or webcams, should be connected to USB 3.0 or higher ports to achieve optimal performance. Power delivery and port type can also affect recognition and stability, particularly with devices that require more current than a standard port can provide. Some installations require administrative rights to proceed. This is common for drivers that make system-level changes or for environments where security policies are in place to control which devices can be connected. Non-administrative accounts may be blocked from installing drivers or altering device configurations. In business environments, these restrictions help protect system integrity and prevent unauthorized hardware from being introduced. Vendors often provide dedicated utilities or management software for their devices. For example, HP Logitech or NVIDIA supply software tools that not only update drivers but also allow configuration of advanced features, diagnostics, and sometimes firmware updates. While these tools can enhance the user experience, they may also use additional system resources. Information technology professionals must decide whether the added convenience is worth the potential performance trade-offs. Offline driver installation is common in secure, air-gapped, or recovery environments. In these cases, the necessary drivers are downloaded onto a separate system, transferred via USB or other media, and then manually installed. Having a library of drivers stored locally or on recovery media can save time when working on systems without internet access. This method ensures that hardware can be configured and used even in isolated environments. The quality of the installation process has a direct impact on the user experience. A smooth, plug-and-play installation results in minimal downtime and requires little user input. Poor driver support, on the other hand, can lead to slow performance, device failure, or user frustration. Understanding when to use plug-and-play versus manual installation improves support efficiency and ensures that devices function as expected in all environments. In real-world support situations, you may encounter many examples of both installation types. A user plugs in a standard mouse, and it works instantly using a built-in plug-and-play driver. A department installs a new printer that requires downloading and configuring a specific driver package. A graphics card driver update causes display errors, prompting the information technology staff to roll back to the previous version. A network scanner fails to operate until proprietary utility software is installed manually. For the CompTIA Tech Plus exam, you may be asked to choose the correct installation method for a device or to troubleshoot an installation issue. Scenario questions could present error messages, missing functionality, or compatibility problems, and you will need to decide whether plug-and-play or manual installation is the right approach. Recognizing the symptoms of installation failure and knowing the steps to resolve them align with both the infrastructure and applications domains of the exam. Key glossary terms to review for this topic include plug-and-play, driver, unsigned driver, rollback, vendor utility, compatibility mode, and device identification. Matching these terms to their related hardware and installation procedures will improve both your exam performance and your practical skills. Reviewing these concepts with examples will deepen your understanding and prepare you for real-world application. In the next episode, we will move into input and output interfaces, comparing USB, Thunderbolt, radio frequency, Lightning, and Bluetooth. You will learn how to identify these connection types, understand their capabilities, and troubleshoot performance issues related to them. Thanks for listening. Please visit baremetalcyber.com for more cybersecurity information and education, including a new children's series. For more information on books and more, follow us at cyberauthor.me.